Yes, I'm
Yeah.
ready.
Yageshwari?
Who is old? Anyone who stops learning is old. Who is young? Anyone who keeps learning is young. A warm good evening to one and all present here. On behalf of the Department of Computer Science, University of Madras, and MHRD RUSA 2.0 Biomaterials team, welcome you all to 2 weeks workshop on analytical tools for image processing, day 9. We all had very useful and informative sessions for the past 8 days. Today's topic is dental image processing using deep neural networks. I request Dr. B. Lavanya ma'am, Principal Investigator, Biomaterials Team, Associate Professor, Department of Computer Science, to say a few words about the resource person.
Ma'am, welcome, ma'am. On behalf of our Department of Computer Science and
Thank you
RUSA
very much.
2.0
Thank you.
Project Biomaterial team, on behalf of our other conveners, Professor P.L. Chitra ma'am and Professor M. Swarnam ma'am, I really welcome you for this 2 weeks workshop on analytical tools for image processing. Before we start formally, I welcome Dr. M. Mary Vanilla, Head, Department of Computer Science, Presidency College, to introduce our resource person for today.
Everyone. I have immense pleasure in introducing today's resource person, Dr. Shanmuga Vadivu, Professor of Computer Science and Application, Ramyam Rural Institute, Dumtwe University to you. She has 29 years of academic experience and has been in the field of research for 2 decades. She actively involves herself not only in teaching and research, but also in academic extension activities. She was graduated BSc Physics from Kundavai Nachiyar Government Arts College for Women, Bharatidasan University, and she did her MCA at REC Tiruchirappalli and MBA HRM from. She has pursued her PhD in digital image restoration from Gandhi Gramyam Rural Institute. She certified both UNET and SLED. Coming to the research perspective, her research area includes medical image analysis, health analytics, parallel computing, digital image processing, software engineering, and image retrieval. She has successfully guided 6 PhD candidates and 19 MPhil scholars. Moreover, 8 PhD scholars on the pipeline. She has published 43 research articles in international journals, 83 in international and national conferences, 13 book chapters on her credit. She is the author of 2 research books and 2 edited volumes. Her science citation index is 21, Google Scholar citation index is 375 with H index and I10 9. She serves as an editorial board member of 2 journals. She has reviewed more than 50 research articles in her area of specialization. 2 of her research articles received Best Paper Award in international conferences. She was sanctioned with major research projects from UGC, DST, ICMR for an outlay of rupees 1.5 crores. She had been on an international academic assignment to Singapore, Malaysia, USA, and China. She has organized a national level conference, a week-long Digital India program, and 2 workshops. She has delivered 80 plus invited talks and more than 70 guest lectures. Her administrative experience includes head of the department, director into IQSC, local coordinator for GIAN, Global Initiative of Academic Networks in higher education. She also serves as a member in Board of Study of other universities and colleges. She has attended MHRD Leadership for Academician Program, LEAP 2019, organized by IIT Bombay, and the second leg of LEAP at Nanyang Technical University, Singapore, March 2019. She is the recipient of Indo-US 21st Century Knowledge Initiative during 2015 on the title, Augmenting the Curriculum of Higher Educational Institutions with an online integrated cognitive-based employability skill assessment system using signal and video analytics, which is one among the 4 projects sanctioned for India with a funding outlay of 1.25 crores. With this brief introduction, I welcome you, ma'am, for the 9th-day session. Thank you.
Thank you,
Oh.
Dr. Mary Vanilla, ma'am.
Thank you, ma'am.
Yeah. The floor is yours, ma'am, Dr. P. Shanmugavadipu, ma'am. We are really honored to listen to you.
Thank you. Thank you. Thanks for your words. It's quite encouraging. And my thanks to Dr. Vanilla too for the introduction. And I extend my hearty thanks to the entire team, which is taking this MHRD RUSA 2.0 on biomaterials forward in the best possible way. So I record my congratulations to your team, Dr. Lavanya, and then Dr. Sarnam and Dr. Chitra. And it is such a vibrant team, and given any task, they will do it just like that with excellence. So congratulations.
Thank you for your kind words. Thank you.
So I'm happy that I'm part of your endeavor, and thank you for the invitation. Now, let me just share my PowerPoint presentation.
Thank you very much for your compliment.
It is not a compliment, it is a fact indeed. So, so I have seen you in close quarters since a few years, right? So you're all focused and you're determined to achieve certain milestones. So by God's grace, it is happening as well. So all my congratulations to you, and my wishes and prayers for you to reach greater heights.
Thank you, ma'am.
And then may all your dreams come true as well.
Thank you, ma'am.
So I trust the slide is visible to you.
Yes, ma'am. It's visible.
Okay. So on behalf of the organizers, I extend very warm greetings to all the participants. Good evening, everyone. And let us record. Am I audible?
And now
Yeah.
it is, yeah, ma'am.
Okay. Okay. Now let us, I think suddenly it goes off. Hello.
No, yes, ma'am. It's audible, ma'am.
It's audible? Okay, perfect. Right. And let's all extend a warm thanks to the organizers for connecting us through online on this special event and on the special topic. My today's topic is dental image processing using deep neural network. And this is a new domain where we try to connect artificial intelligence with dental or dentistry, because this neural network has got tremendous potential for managing the images. So it is equally important to explore the possibility of deep neural network on dental images too. So, 1 minute. Well, so let me get into my topic. Actually, I'm supposed to handle 2 sessions, 2 consecutive sessions, one today and the other one tomorrow. Due to a few reasons, I have requested the organizing team to give me, to shift my slot to Saturday, and I thank the team for doing that also for me. Thank you very much. So this is the roadmap. Let us start with an overview about artificial intelligence, then a brief introduction about deep learning, then let us focus on deep neural networks, then deep neural networks, DNN in short for dental images, applications of deep learning on dentistry. So let us try to cover as much as possible till 5:30, and then we can continue the remaining topics on Saturday. So he is the great personality who is deemed to be the father of artificial intelligence, John McCarthy. And you all must be knowing about the evolution or the birth of artificial intelligence. It all happened when John McCarthy decided to go for submitting a proposal for financial funding to organize a brainstorming session. So he just wanted to explore the possibility of implementing artificial intelligence as well as to formulate a theoretical framework for artificial intelligence. So when he was preparing the proposal, he coined this word artificial intelligence, and subsequently he developed Lisp programming language, which is a typical programming language that we used when we were in the college. So those who did their college education in late 90s, like 1990, 1987, 1995, they must have come across Lisp programming in their curriculum because this was considered as a tool for learning the implementation of artificial intelligence. So when I was in the college, when I was in NIT, then it was REC, we had a paper on Lisp programming, and we did have a paper on artificial intelligence. And at that time, there was a big talk about artificial intelligence, stating this is going to have a big boom and that is going to take a different impact on the technology, lifestyle, and every walk of life. But somehow it didn't have a much takeoff. And now, thanks to all the technological advancements that really triggered the growth of artificial intelligence. So coming back to the contribution of John McCarthy, he is the one who coined the word artificial intelligence. In addition to that, and he developed a Lisp programming language family, as well as he substantially contributed for the design of ALGOL, that is algorithmic language. And he was instrumental, or he contributed tremendously to implement the concept of time sharing, which plays an important role in the modern operating systems. So he was very influential in the early development of artificial intelligence. He took all pains to give a kind of a theoretical structure or theoretical components for artificial intelligence. So why are we worried so much about artificial intelligence, and why do we want to infuse this artificial intelligence into our research? And what is the need for us to learn about artificial intelligence, and why people say that this artificial intelligence is going to rule the entire world in the coming days. So this is a branch of computer science dealing with simulation of intelligent behavior in computers. So this is the keyword, quote unquote, simulation of intelligent behavior. When we say intelligent behavior, it goes without saying it is intelligent behavior of human being, right? So what do we understand by the intelligent human behavior or intelligence of a human being? And can any one of you please open the chat box and then let me know how do we how can you probably measure the degree of intelligence, or what are the activities which simply reflect the degree of intelligence in human being, please? You can just chat. What are the essential activities of a human being that demands intelligence? And for that matter, any activity cannot be done without the support of the brain, but still we can just list a few important topics. The speed in which how smart the work is done. Perfect. You are right, smart work, doing it in an intelligent manner. So this is how we do it. But in addition to that, what are the factors through which we can, decision-making capability. So I should thank Dr. Balamurugan for this. Decision-making capability, this is one aspect. So the way we talk, right, the way we have a visual perception, you look at something and try to understand, try to infer some information. So visual perception, And then the way in which we exactly, thanks to Dr. Jennifer, and the way in which we converse, the way in which we speak, the way in which we understand, the way in which we, grasp something from conversation. So your speech processing, and then your thinking ability, and then you try to understand something in the form of a text, something in the form of an image, something in the form of audio, right? Anything, everything is possible with the support of the brain. And then decision making, then you try to strategize certain things, as it was rightly pointed out, as smart work, right? So all these things are essential. Analytical reasoning, then reasoning ability, logical thinking, these are all the essential factors which are supported by the intelligence of a human being. So decision making, then being strategic, and then contextually responding to a situation. So like out of this context, I'll ask you a question, because everyone is educated and everyone is having good knowledge about what to do, how to do, when to do things. Now, what's the difference between being active and proactive? Can any one of you just text on this? And how do you want to be? Whether you want to be an active person or proactive person? Because it has an important impact with respect to deep learning neural network also. As a personality, whether you want to be an active or proactive, again, there's a response. Okay, well, proactive, right? Proactive, perfect. Why not active? And what is the difference between active and proactive? Even we react based upon some situation, right? So whether we want to be active or proactive, it should be based on a situation. Yes or no? Yes. Controlling the is it controlling the situation or controlling oneself with respect to a situation? What is the main? Can any one of you state the difference between active and proactive? Or we can just put it as reactive and proactive. Let us make active as reactive and proactive. Well, see now responding to an event, reactive, right? Thinking the future and make decisions, proactive. Okay. See, when you are not mentally prepared for a particular situation, when it happens, and when you instantly react without having any control over your brain and the thinking process, it's called as active. On most of the occasion, when many of us are very angry, right? When we are in the clutches of anger, so we can never be proactive. That's a typical situation for being reactive. And we know, suppose if you enter into the house, you know, probably your child will be angry with you, or your husband will be angry with you, or your wife will be angry with you, your parents will be angry with you, or your in-laws will be angry with you. When you enter in, when someone blasts at you, and when you blast back, it is reactive. Now, when someone blasts at you, you just take some time back and then understand the situation. And if you can manage it without blasting back, but still, if you can handle the situation, that is called as proactive. So you keep your mind prepared to handle any situation. So whether it is good or bad, right? You are prepared. So when you are prepared, then you have a kind of controlled behavior. So that is why it is called as proactive. So yeah, well, there is a response from Dr. Meenakshi. Active is ready to face any situation, and proactive is, according to the situation, the change in normal reaction. That's right. This is active as being then active. We can call it as reactive. See, when I react without bothering much about the consequences or without having good understanding about the situation, that is called as reactive. And when I know that if I am going to shout back, it is going to worsen the situation, let me keep quiet and then give the explanation a little later based upon the temperament of a person, that is proactive. So this is just an example. And this should be correlated to any situation. So being highly educated, being the personalities holding the highest academic degree, right? It is high time to introspect into ourselves and then try to brand ourselves whether we want to be proactive or reactive. Request, I can't change my pet name. Kindly note my name, mail ID, Jhansi Rani. Okay. It's okay. Okay. Right. Thank you. So now let us get back to this, right? Because now we are going to learn about these kind of convolutional neural network. They are going to learn and then be ready to handle the situation. So now the core idea behind what we want to take away from this conversation is, now whatever that a person can depict in the form of conversation, then writing something, reading something, learning something, then the visual perception you have, then articulating skill that you have, these are all elements of intelligence. So we are trying to mimic a system which can have visual perception that you call as computer vision, and ability to read, write, speak, understand. We call that as natural language processing. And then you can do any kind of problem solving that is done with the help of machine learning and deep learning. So it can be analytical ability, or it can be reasoning, or it can be logical reasoning, logical problem solving. Everything can be done by a machine, provided if we can impart the human intelligence into the machines. So artificial intelligence refers to systems designed by humans that, given a complex goal, act in a physical or digital world by perceiving their environment, interpreting the collected structures or unstructured data, reasoning on the knowledge derived from this data, and deciding the best actions to take, right, according to the predefined parameters to achieve a given goal. See, whenever you have a problem to be solved, you may have some goals to be achieved, whether you want to do the disease diagnosis, or you want to do some natural language processing, translating a speech into text or text into speech, or a speech in English to some other regional language, many such things. So it has got a specific set of goals to be achieved. So that is being done with the support of artificial intelligence. Okay, so it's a machine's behavior simulated as human behavior, point number one. That is what we were talking about today, essential capabilities of human intelligence. Then designing machines that can act and react, adapting their responses to the demands of the situation. See, now in the lower classes, we were taught how to add two numbers. But now we are able to extrapolate our learning, and now we are able to apply that basic knowledge to add any number of, two numbers running to any number of digits. So we are able to adapt the responses and as the situation demands, then display of behavior compatible to that of intelligence in humans. Now, that is whatever that human being can do, and that should be possible with the support of this artificial intelligence. The act of creating machines that perform functions that require intelligence when performed by people. Okay, so you can see here in this diagram, now a machine is sitting and learning because it has to perform machine learning or deep learning, whereas now machines are hooked to books, that is learning, and humans are hooked to machines, right? So these machines have the capability to learn, but whereas we become slaves in the hands of those machines. So then no humans are required. Artificial intelligence algorithm can provide solutions. Artificial intelligence algorithms can provide optimal solutions, and AI is contributing to the transformation of society and industry revolution. This is about a 2 years old data, it can be even still faster, say 50 times faster, 500 times the scale, or even 1,000 times the impact, because every day it is drastically, radically changing. So artificial intelligence can enable humans to focus on parts of their role, then add the most value, right? So this is going to be a value addition when you try to manage this problem solving with the support of a machine. So it is the most essential one. See, as we just trace the growth of artificial intelligence, it just started way back in 1950s, because in 1956, John McCarthy came out with that word, artificial intelligence. So this neural network was picking up between the year 1950 and 1970. And early work of neural networks is the excitement of thinking machines, because for the first time, we were able to write programs which can mimic the behavior of a human being, like decision making, or it can be logical thinking, right? Then reasoning, all those things. Then between 1980 and 2010, and this artificial intelligence was narrowed down into a well-defined framework called machine learning, with a collection of algorithms, like as we take linear regression, then logistic regression, multinomial regression, decision trees, support vector machine, Bayesian classifier. These are all the typical examples of machine learning algorithms. So then they had an array of models, and their models were fine-tuned, and things were going like this. And now the present day is focusing on machine learning approaches. So deep learning breakthroughs drive this artificial intelligence boom. That goes without saying, right? So okay. And so to focus more on this, you can just see these domains. It is like deep learning in the core. So, the first one, we start with artificial intelligence, which is the broader umbrella under which you have machine learning, then neural network. This neural network was leading to deep learning, right? This is for deep learning, the basis is convolutional neural network. So this artificial intelligence, the term used to describe the theory and development of computer science, which can perform tasks that normally require human cognition, this human intelligence. That's very, very important. So then machine learning, that is, there are a good number of mathematical approaches in which algorithms are applied to learn the intrinsic statistical patterns or structures, or it can be probability-based structures or patterns in the data. See, for instance, when you take a data, we just try to see what is the common pattern, which can be characterized by, say, mean, median, mode, percentile, or kurtosis, skewness, or interpercentile. So these are the statistical features which may help us to identify what is the common thread or what is the common feature that exists in the entire set of data. In addition to that, based upon the available data, we can see what is the probability of occurrence of one particular character or one particular event, which can give rise to or which can help us to go for subsequent prediction. So these neural network models are built on the idea of artificial neurons inspired by human brain. So all of us must have learned about the functionality of biological neurons, that is the human nervous system. So the entire nervous system is being connected to the brain, and the brain is the governing body. That is the core control system that takes care of entire body, whether it is internal or external, the entire set of parts of the body. So a model is built on the idea of artificial neurons inspired by the human brain, which are fully organized and connected in one or two hidden layers. So whatever that is there in the form of biological neuron, that was mimicked to construct this artificial neural network, or it can be a convolutional neural network. And later, the kind of success inferences which were got out of this NNN has led to the development of deep neural network or deep learning. And NN models with multiple hidden layers allowing for very complex features to be learned, like edges, corners, shapes, and macroscopic patterns from the images. See, now when you take an image, the image can be characterized by if it is closed lines, it is boundaries, and if it is discrete lines, it is called as edges. Or it can be a particular shape. Suppose if you want to identify some carie that is present in the dental image of a tooth, then we must be able to locate it and try to see what is the severity, how far it has spread. So it is the shape as well as the macroscopic patterns from images. Now, suppose if you want to zoom and then see, and if you want to magnify a particular region and see, then we have to go for the macroscopic view of the given image that is called. This is done by CNN. So the extended version of CNN is a deep learning. So this is the biological neuron, that is human brain. Then machine learning involves interconnecting the dots and then apply the algorithm and try to see how to extract the maximum similarity between the patterns and how to identify the features that express similarity or dissimilarity. Then coming to this NN neural network, all of you must be aware of this. And there is going to be a set of input layers. Then there will be an output layer, and in between this input and output layer, we have this hidden layer. So it can be one or many, right? There can be one hidden layer or there can be multiple hidden layers.
Two times.
So now coming to this deep learning, now what is the need for us to think about deep learning? Manually designed features are often, I think one of the participants' mic is on.
Have you muted, ma'am? Please continue.
Okay.
Yes, yeah.
Well, so this is kind of refreshment for us. Well, listen to a babe's voice. Okay, then what is the need for deep learning? Manually designed features are often overspecified, incomplete, and take a long time to design and validate. See, now, suppose if you don't go for deep learning, what we should do, we have to extract the features manually. Then these features have to be fed into a neural network for subsequent processing, like it can be for classification, or it can be for decision making, it can be for prediction, things like that. And now in the case of neural network, the neural network will be able to extract the features automatically by itself. So we don't have to go for manual extraction. So that's the reason why the first point states manually designed features or extracted features are often overspecified, or it can be incomplete in the sense, and it may take a long time to design and validate. The learned features are easy to adapt and fast to learn. And then it provides a very flexible, universal, learnable framework for representing world, visual, and linguistic information. So this provides a very flexible, universal, and learnable framework for representing world, visual, and linguistic information. That is anything that is realistic, anything that is available in the real time. It's possible to be handled by the deep learning neural network. Can be either supervised or it can be unsupervised. So then requires large amount of training data. Now, suppose if you have only a handful of data, then you cannot manage with deep learning. And that requires good amount of data, right? To perform this art of deep learning. Okay, So now we can see why deep learning. Traditional pattern recognition models use handcrafted, that is manually removed features, and hence it is very probably difficult to validate whether the extracted features are or more or less in comparison to the required degree of information. So handcrafted feature extracted, we have to extract the features like eyes, nose, things like that. Then simple trainable classifier should be taken to understand these features and then transfer it or classify or predict, give the output. So the limitations are it is very tedious to develop handcrafted features, point number one. Then handcrafted features are problem dependent as well as they are generic. Suppose if I want to develop something for a tiger or for a leopard, then that may not work for, say, zebra or anything else which is having a radically different features. So that's very important when you develop the model. It should be problem specific. So deep learning, representing the process of learning, seeks to learn rich hierarchical representation features automatically through multiple stages of feature learning process. See now the point is here, in the case of this handcrafted features extracted, then you use a simple a classifier that will help us to do the kind of classification. So then the next one is the output. In the case of deep learning, low level features are extracted, mid-level features are extracted. We can see here because every one of you must be having some information about bit planes. When you take an image of size, say 8-bit for each pixel, then naturally it is going to have 8 pixels. So when I try to combine the 0th pixel of all the pixels in the image, that becomes bit 0. When I try to combine all the bits which are representing 1 for each pixel of the given image, that represents a bit 1. Now here goes a question for you. Once again, IGHT. In an 8-bit image, image of size 10 into 10, how many bit planes are there? In an 8-bit image of size 10 cross 10, how many bit planes are there? Yeah, I'm expecting answer from you. For an 8-bit image of size 10 cross 10, how many bit planes are there? So I'll give the answer. Suppose if I have a pixel, right, whose intensity is, say, let me take a pixel. whose intensity is 10. What is the 8-bit representation of this? This is 10 base 10. What is the binary representation of this? What is the binary representation in 8-bit? There is an answer as 800. Okay, let me finish this and then let me validate the answer. A pixel whose intensity is 10, right? What is the binary representation in 8-bit? It is 0, 0, 0, 0. Well, it is 0, 0, 0, 0, 1, 0, 0. Thank you. Now, you call the leftmost one as the leftmost bit 0 as leftmost as what? Leftmost bit as least significant bit, right? And the rightmost bit as most significant bit. Okay, so when I have an image of 10 cross 10, how many pixels will be there? MSB, right? So when I have an image of 10 cross 10, how many pixels are there? 10 cross 10 image. Well, the number of pixels are in 10 cross 10 image, 10 cross 10 is 100. So there will be 100 pixels. For each pixel, I am going to give an 8-bit representation as we had as 0, 0, 0, 0, 1, 0, 1, 0. So when I arrange them all one after the other for pixel 1, pixel 2, pixel 3, pixel 4, up to pixel 100, whatever that lies on the LSB position, that is taken as bit plane 0. The second position, the one that is lying on the right of LSB, that if you combine all the 100 values of all pixels in a particular position, that is bit plane 1, then bit plane 2, bit plane 3, bit plane 4, bit plane 5, bit plane 6, bit plane 7 or 8. If you start with bit plane as 1 for the first one, it is 1 to 8. Otherwise, it is bit plane 0 to bit plane 7. Now tell me how many bit planes will be there in an image of size 10 cross 10 with the 8 bits. Eight bit planes, right? And now here the point is when I take the bit plane, 0th bit plane, it may have very less amount of information. When I travel from the least significant bit plane to the most significant bit plane, the bit plane 7 or bit plane 8, depending upon the requirement, may have the maximum intensity value. Okay, so as we go for this, we can classify them by combining the bit planes. We can go for the representation of low-level features, mid-level features, as well as high-level features. So this kind of extraction can be done by deep learning models, and then it is being fed into a trainable classifier, the one that you have here, the trainable classifier, and then you can go for likewise. So hope it is clear to you. What do you mean by these bit planes and the respective features? So you have the trainable classifier output. So here in the case of ordinary method, this is handcrafted. In the case of these three, it is machine extracted. It is done automatically. That is the main advantage of deep learning methods. Otherwise, it is just the same as that of ordinary one. So the impact of machine learning, it finds application in speech recognition, then in computer vision, machine vision, or in formulating or designing a recommendation system or recommender system, then language understanding, then in advanced science and technology related operations like drug discovery, medical image analysis, image processing, medical image analysis. So our domain of dentistry lies in this medical image analysis. So these are the generic steps of deep learning. We have to collect data. The data, it can be image rather. Then the data has to be cleansed, and then we have to prepare the data suitable for processing. And if necessary, we have to manipulate. If some noise is found or if some errors are found, then we have to go for some cleaning. We call that as data imputation. We try to modify it. Then training the model is the one. You have to take a subset of the given data set, and that should be given to the model. The model, depending upon the algorithm that you give, it tries to establish the relationship between the given input data as well as the output data, right? At this point, we should know what is meant by supervised learning, what is unsupervised learning. Now, if you make the machine to understand any data by giving the input data along with the output data, you make the data understand what is the relationship between the input parameters and output parameters, and that is called as a mapping function. So by mapping the input parameters to the output parameter, the model itself builds a mapping function as y is equal to f of x. So then after that, it tries to find the association, how this can be mathematically be represented. So after you train the model, then you test the model and check its accuracy, its validity, and then you try to improve it so that that model can be deployed. So these are the essential steps. So as we talk about deep learning tools like Python, Spark, Matplotlib for visualization, or we can use Tableau or the machine learning tools like Spark, right? Scikit-learn. This is again a set of library that helps us to work on this. Then Keras for deep learning and TensorFlow. Now, as you compare between machine learning and deep learning, now the deep learning is going to be computationally complex, number one. It may be able to handle a large volume of data with ease. So to discuss about this neural network, this ANN that you call as artificial neural network or neural network, are machine learning computational algorithm modeled after a human brain and its functionality. So it's a technology based on structure of a neuron inside a human brain, which consists of a number of artificial neurons, right? So it's technology that is based on the structure of neuron inside the human brain. You know how the neurons are being connected. There's a chemical reaction takes place. It transmits the message from one neuron to another neuron. So we know about it. Now it will try to create a function to map the input parameters to the desired output. And then it is a simple mathematical model which is used to process nonlinear relationship between the inputs and outputs in parallel, like human brain does every second, right? Because when you are like the input and output are discrete, right? When you are listening something, you can see something because that input goes separately. So like this, you can do multiple tasks. You can be Ashtavadani, Dasavadani, right? You can do multiple tasks. That's possible. Support of your active brain. Okay. So to just get a grasp of what is happening in artificial neural network, now, three things are there in this artificial neural network. Point number one, it is the input, right? X1, X2 up to Xn. Then you have the output, which is always called as Y. In machine learning, deep learning, we refer to the inputs by means of X1, X2, X3. And then the output is represented by Y. Okay, so now we can see here for each and every input parameter, there are some weights being added. Now, these are the weights which help us to make the network to understand or prioritize the input parameters, right? So this is used for prioritizing, and then we we just multiply every x component with its respective w component. So it is xi multiplied with wi plus b. Now this b is a bias value, right, which says, suppose if all the weights happen to be 0, then ultimate sum of this multiplication will be 0. So to avoid that, what we do is we try to incorporate a non-zero quantity. And even by this multiplication, if the term becomes 0, this b will help us to have a kind of non-zero item. And then once it is done, then it should be converted by using an activation function. So it is, this is a mapping function that maps the relationship between, or that discovers the relationship between the input parameters and the output parameter. I think you can see here x1, x2 up to xn. These are the input parameters. And then you have w1, w2 up to wn. So now we are going to have, one-to-one multiplication, x1, w1, x2, w2 up to xn, wn. Okay. And then you have this x1, w1, x2, w2, whatever that you have. This is going to be represented by this terminology, right? Sum of xi multiplied with wi. So we are going to do that. And that will give you some value, right? So that value is going to be used by the activation function for subsequent operation. So it is x is the input, w is the weight, b is the bias, y is the output, and f is the activation function. So this is what happens exactly in a neural network, right? These are the three inputs, x1, x2, x3, x4. So the weights are 0.7, 0.6, 1.4. So we multiply them together, and then you find the sum of all those products plus bias, and then that will help us to get f, that is the mapping function. And lastly, you get the output. So NN can be used to solve problems related to tabular data, image data, as well as text data. It is capable of learning any nonlinear function. Any nonlinear function, if the input is 1, output is 2, input is 2, output is 4, input is 3, output is 6, it is a linear function. Sometimes it may not be linear, then necessarily you have to find a strategy to handle this, and machine learning is possible. So it is capable of learning any nonlinear function, hence it is known as universal function approximator. And then it has the capacity to learn weights that map any input to the output. So one of the main reasons behind the universal approximation is the activation function. Okay, so active functions introduce nonlinear properties to the network, and this helps the network to learn any complex relationship between input as well as the output. So thus, the input at each neuron is the activation of weighted sum of inputs. Because here, now this is going to be passed on for activation function. So it takes the weighted information with respect to x and w. Then it finds the sum that is going to be used for the entire process of finding a solution with respect to given inputs. So this is what you call as deep neural network, is defined as training the NN with many hidden layers. So this is a very simple definition for this. So deep NN is defined as training an NN with many hidden layers, right? You can see here the hidden layers are 1, 2, 3, 4. So it can be, there is one input layer, there is one output layer, all put together 5, the hidden layers are 3. And here there is no restriction to increase the hidden layers also. but though it increases the complexity, probably it can pay off in the accuracy, right? If you want to have highest accuracy model, then we can design a complex network, and then we can use it for producing highest accuracy. So, artificial intelligence leading to machine learning leading to artificial neural network, and then the last one is deep neural network. So you can just have a look at it, then I can just explain to you. Well, so we just start with data set. As I told you, we have to go for data cleaning or data imputation. We have to take care of the missing value, and we have to take care of redundant value, and we should take care of any value which is mistyped or misrepresented. So then after you clean the data and becomes clear, then you go for feature engineering. That is, we have to extract the features. And once the features are extracted, we can try to minimize the features that's called as dimensionality reduction. If I have 100 features, and if I want to construct a neural network with 100 features, how many input? For a problem, in a problem, I'll just give. In a problem, if there are 100 extracted features, there are 100 extracted features, right? Yeah, please respond. In a problem, if there are 100 extracted features, how many input nodes are required? Please respond. As there is an answer, well, it is 100. So if there are 100 features, I have to design a network with 100 input nodes. See, now just imagine there is going to be a hidden layer, and for each neuron, it is going to get connected to the node in the hidden layer. So that will make the entire process is very complex. As you see here. See, look here. See, for each one is being connected to the other one. See, 1, 2, 3, 4, 5, 6, 7, 8. And here it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are going to be, each one is connected to 9. So it is 7 into 9, right? So there are going to be 63 connections here. So now if you increase this to 100, then this becomes 900. So it is going to get increased multifold. So that is the reason why, right, as we have more number of layers, we understand that's going to increase the complexity of the given data. Right? So you do the feature engineering, feature extraction. And then you go for training. You know what is training. Now we have to partition the data set in the form as required. It can be 50-50 or 60-40 or 70-30 or even 80-20. Now you keep one for testing, and then the remaining, say, let us take 70-30. 70% of the data set will be chosen for training. And then we try to see what is the response of the model that we have developed with respect to the new data. So this training data is going to be given to a model for learning. You take the learning algorithm, you have the training model, and then we try to extract it. And then down, you just come down and then you score the model. Now you have to just check now you have prepared or developed a model, that model should be validated with respect to new data that you have, right? So now when you go for testing with the new data, in the case of training in supervised learning, we give both input and output. But in the case of this, we don't give, while testing, you don't give the output, you just give the input. So we try to test and validate what is the degree of learning of the model based on the data that is present or the data that is given for computation. So we just score the model, and then we evaluate the model. So this is the entire process of deep learning. And anything that you learn with regard to this kind of a representation or this kind of format, right? So you are going to have new data, and then that is the one which doesn't have the output. So that will be taken, then you run the system or run the model, try to evaluate it. Suppose if it is accuracy is, say, if you expect 90%, and if the accuracy is 60%, probably we have to change with respect to the features that we give, or there are certain parameters being called as hyperparameters for each algorithm. When it is linear regression, it has a set of hyperparameters. Similarly, for decision tree or for other models, right? You are going to have a set of hyperparameters. Those hyperparameters can also be adjusted to get the maximum expected accuracy. So we call that as the evaluation model. So we evaluate and then see whether it is suitable for deployment, that's whether we can implement it, right? So now what is meant by an activation function? An activation function is a powerhouse of deep neural network. And an activation function is used to map the input to the output, right? I told you about mapping. So that activity is well done by this activation function. It normalizes the input and produces output. Then it is passed forward to the next layer of neurons, right? So when you do the computation, you get some intermediate value, which may not be of the form to be interpreted by the machine. You may have some kind of, unbounded value, which cannot be used for convergence. So on such a situation, we take this kind of unbounded data, we apply some transformation function, or we apply some activation function, which converts the given set of data into the form which can be more understandable and based on which the model can interpret and take appropriate decisions. So this helps to learn complex relationships and patterns in data, thus add learning power to deep neural network. So two important uses of the activation functions are to keep output restricted to the particular range, right? Suppose if I fix it as 0 and 1, whatever be the data that I have got as intermediate data, all those data should get converted into the form, say, between 0 and 1. So this is what happens. So take the input and multiply with the neurons weight. Hope you will be able to recollect x1, w1, x2, w2. So you find the sum of all these things, then you add the bias value, then feed the result x to the activation function f of x, then take the output and transmit the next layer of neurons. Okay, So this is going to be continuous and then until it reaches the output. Well, so these are the different activation functions that you can see by their representation. So this is zero crossing that happens between 0 and 1. And this is also zero crossing. This is not zero crossing. And this is also not zero crossing. So it used to determine the output of neural network like yes or no. And then it maps the resulting values between 0 and 1 or -1 and 1. The range can be anything. So depending upon the type of activation function that we select, accordingly, this is going to happen. So this is an example how you will get the transformed values mapping. It is sigmoid or logistic function, and this is tan H. And this is called as logistic regression or sigmoid. This is called as one second. So this is called as hyperbolic tangent, that is tan H. And then this ReLU stands for rectified linear unit. You can see how it is getting mapped. At any value which is negative to 0, they are mapped to 0. They are transformed into 0. Then the remaining values are just represented by means of any value that lies between this and this. Right here, as you see here, anything beyond 0 will be mapped, and then accordingly it is. And this is a kind of straight line, and this is another shape. Okay, I think I have gone far. Okay. So now we have to pay some attention on training, validation, and testing or holdout data set. So as I told you, the split can be anything, and normally it can lie between the range of 60 to 80%. The first step in developing a DNN learning model is training and validation by partition the data set which involves choosing what percentage of data to use for training, validation, and holdout. So the sample data that is used to fit the model, we call this as training process. That is used to fit the model, and then it uncovers or learns relationship between the features and the target variable. Then the next one is validation. It can be 15 to 25%. The sample of the data used to provide an unbiased evaluation of the model. That is, when you give both input and output, then the model gets biased. It understands what is the input and what is the output. When you give the unbiased data, it is a fresh one for it, and the model can respond. So it uncovers or learns relationship between the features and the target variable. Then validation set is the sample of data used to provide an unbiased evaluation of the model fit on the trained data set while turning model, for the purpose of fine-tuning the hyperparameters. As I told you, suppose if you're working on the decision tree, then you have to decide how many leaf nodes will be there and what is the depth of the tree and which node is going to be used as, which feature is going to be used as a root node for which you calculate the entropy and then information gain. So these are all are referred to as the hyperparameters. So the sample of data used to provide an unsupervised evaluation of the model fit on the training data set while tuning the hyperparameters. So in the process of training, we tune it and then we try to check what is the accuracy, what is the error rate, and things like that. So it is used to find how accurately it identifies relationship between the known outcomes for the target variable and the data set's other features. So now with the known values we have tested. Now with the unknown values to the model, we try to do that. Okay. So this only the distribution of the percentage. We can have a look at it later. Okay. Testing data is the sample of data used to provide an unbiased evaluation of the final model fit on the training data set. It also provides a final estimate of model's performance after it has been trained and validated. So once these two are being done, then we can go for testing. So train model on training data set, evaluate the model on validation set, tweak model according to the results on the validation. We have got the validation, right? So based upon that, we have to fine tune it. Then pick model that does best on validation, then confirm the results on test data. So you know what is training, you know what is validation, you know what is testing. Because I wanted to focus on this before we move on to the core aspect in the first session, because whenever the researchers are working in machine learning or deep learning, they just skip or drop the data or statistics on fine-tuning the model. That is very, very important. So how do you fine-tune the model? What are the parameter values that you adjust to get the maximum value? That's very important. So any model, any machine learning model can be categorized into underfit model, overfit model, or good fit model. So before we go into it, please look into this. So you can call this as a scatter plot. Now we want to draw a straight line. So this straight line must be able to separate two categories of data representation, one in the form of a puzzle and one in the form of small circles, right? See, you are going to design a mathematical function as y is equal to f of x, and that must be able to identify or separate the bubbles from the into mark. That's the whole idea. See, when I do that, right, you can see here, there are a lot of misclassification. So this into mark has come here, and then now there are misclassification. We are supposed to have a line which covers all the into marks on one side and all bubbles or circles on the other side. But here we can see the into mark is lying here, then bubble is lying here, bubble is lying here. Okay. So the next one is you can see it is able to learn and then it is able to separate at the maximum with maximum possibility or accuracy. So this is quite normal, like human brain, how human brain learns from the basics and then applied. See, as you see, overfitting, now there's no misclassification. Even here, there is misclassification. And it is able to take each and every point and does it. See now, suppose if we are giving a question and answer to a child, right, to learn it and then write it. See, if the child by hearts completely, then it just produces that. And if there is a question for the child to think on its own and do it, it won't be able to do because its brain is trained on predefined data. In the similar way, when you give some statistics and the statistics is properly applied, and if it is going to pick each and every point, then we call this as this is an example for poor learning, right? So what is learning? Learning should make us understand certain thing and we must be able to apply the idea. So it should not be a confined learning model. Whereas in the case of overfitting, there is no misclassification. If the misclassification is 0, that is a typical example that model is biased. Okay, what is biased? You are biased about the input and the output. The model knows if this input is 1, then the output should be 5. And the input is 2, then the output should be 7. So this is going to be false. So this is called as overfitting, where there is no misclassification. So as we talk about the error and then model complexity, see the error is, this is the training error and then this is the So here it is underfitting, right? This is leading to overfitting. So this is the correct point, the middle point, right? So this is the correct point which helps us to converge to the middle value. So as you see here, right, as the model complexity increases, right, and then the training error also decreases. And if the complexity is very minimum, then the error rate is very minimum. So this is the association. So the best fit lies here. So this is best fit. The good governed compromise is called as best result or best accuracy, right? You must be able to understand. So what is underfit model? A model that fails to sufficiently learn the problem and performs poorly on the training data set, and it does not perform well on a holdout sample. Okay. What is overfit model? A model that learns the training data set too well and performing well on the training data set, but does not perform well on the holdout data. So this is called as overfit model. For training, it will give 100% accuracy, but when we go for testing, it will give 30%, 40% accuracy. So good fit model, a model that suitably learns the training data set and generalizes. What is generalization? And if a person knows a mathematical concept, that concept should be, he or she should be able to apply for any kind of data, right? That is called as applicability. So these are the three models, and so you have to record all these things. So regarding this overfitting and underfitting, to avoid overfitting, what should we do? These are the strategies. Train the model with more amount of data. Then you have, suppose if the data size is very small, then you can go for data augmentation. Then addition of noise to the input data. You can add some noise so that the kind of quite similarity between the data can be little broken. The model will be able to, it is like just giving a pinch when you're sleeping. So when you give the noise, the model will just get awakened and then see there is something wrong and how should we manage. Then feature selection should be revisited. Then cross-validation can be, thought of. Then regularization, this is a big topic, and those who are interested and if you want to do core research, you should understand all these things. Then ensembling is the approach where we try to combine the models together, one or two models together, either parallelly or sequentially, and make use of their responses. Then early stopping, this is one of the solution. Now, suppose if you just allow the model just to get iterated again and again for a long time, then probably it may learn. If you stop it at the early stage, less number of iterations, then the chance for learning each and every data will be reduced. Then it is adding dropout layer. This is dropout layer is the one when you have a neural network, when some of the nodes are not responding or not contributing. Just 1 second, hold on. That is one thing. And if you identify certain nodes which are not responding, which is not contributing to the entire model, those items can be, or those nodes can be dropped. That is what we call as adding dropout layers. That is, we try to drop. Then to avoid underfitting, we have to decrease regularization and then increase the duration of training. We have to allow the model to spend more time on learning the features. And feature selection should be focused on. You have to remove noise for handling underfitting, that remove the noise available in the data. Okay, overfitting and underfitting. Yes. Hello. So overfitting and underfitting are two biggest causes of poor performance of the machine learning algorithms and models. The scenario in which the model performs well in the training phase, but it gives poor accuracy in the test data set is called overfitting, right? The scenario in which the model performs poorly in the training data set, and as it cannot deliver features from training data set. So to achieve a good fit of the good fit means to stop training the model at an optimal point, such as the model is neither under observing features nor learning the necessary details and the noise in the training data. So it becomes highly general, right? It is not biased on the data. It is very generic to learn the features. So the extrapolation of that learning process will help the model to behave like a human being. So there are a few more slides. I'll just finish with this tomorrow. I mean, day after tomorrow, we can start with dentistry. So bias now, please try to understand. We already, we came across a bias with respect to some of the products of input and the weights plus bias. This bias is different. This is a statistical measure. Is the difference between the model's average prediction and the expected value. And this is the variance of the data is the variability of the model in case where different training data sets are used. Okay. So then the next one is characteristics of the biased model. The characteristics are the model can be underfitting, or it can have low training accuracy, or it can have the inability to solve complex problems. If it is biased, these will be the features. And the characteristics of model with variances, it can lead to overfitting, or it can lead to low testing accuracy, or it can be like overcomplicating a very simple problem. As you can see here, this is the complexity, and if it is underfitting, it is low complex, high bias, and low variance, right? And if it is overfitting, then it is highly complex. This is due to low bias and high variance. Okay. So when you are developing any model on certain data set, please ensure you record all these things and try to give some explanation about the statistical measures you get, and try to associate, correlate these findings with respect to the characteristics of data. That will give a new flavor to your paper. So detection and solution to high bias problem if the training error is very high. Right, that causes high bias. So train longer, train more complex model, train more features, then decrease regularization. Then you can, suppose if none of these strategies work, then you have to think of throwing away that algorithm and taking a new algorithm, because we have to conclude this model is not suitable for the data set and its feature pattern. Then detection and solution to high variance problem. If the validation error is high, then we have to obtain more data, decrease the number of features, increase regularization. And if not, we have to go for a new model architecture. You can see here, if it is highly biased, low variance, now all these results are focusing on certain point, right? There is not much variance between the values of time. But however, the target is here, the central point, that this is the bullseye, right? It is here, it is getting populated. In the case of high variance, each one is giving some variable, a varying variance, right? And there is low bias because they are not grouped together. There is no bias among the data, but there is high variance. So you have to think of optimization. After you develop a model, you have to think of how to optimize it. So the goal is to hit the sweet potato, sweet spot of maximum value of optimization. And while foolish risk is balanced against excessive caution. Sometimes, due to excessive caution, we may not be able to hit upon the right solution. So optimization is a process of searching for parameters that minimizes or maximizes our function with respect to the parameters. So generally, MLDL models usually use indirect optimization. Certain metrics like accuracy, precision, recall indicate how well your model solves a given problem. But when you go for optimization, you have to think of RMS prop, ADA boost, which is a high-level optimization. However, optimization with respect to relevant cost function, of course, any cost function is specific to a problem, is a big boom. Okay, and now let me continue with these optimizations in the next class. And I have some 40 more slides to go, and I think we will be able to continue this in the next class. On Saturday.
Okay.
Hello. Hello.
Yes, ma'am.
Yes. Shall we stop at this point so that we can continue on the next class and try to finish the rest?
Yes, ma'am. Yes, ma'am.
Okay.
Well, thank you, ma'am.
Thank you. The participants can come prepared with more questions. Before we start with the next session, probably we can try to clarify whatever doubts they have regarding whatever we have discussed.
Bhageshwari there?
Yes, ma'am.
Okay.
Good evening to one and all. I deem it a great honor to propose the vote of thanks to all who have helped us in making this 2 weeks workshop, day 9, such a resounding success. At the outset, I thank our resource person, Dr. P. Shanmugavadivu ma'am, Professor and Head, Computer Science and Application, Gandhigram Rural Institute, for your valuable time and for an informative and interactive session, ma'am. We are eager to hear from you again on Saturday. Thank you, ma'am. Thank you once again, ma'am.
Thank you. Thank you very much. I thank Dr. Sarna Madam, Dr. Chitra Madam, Dr. Lavanya Madam.
Thank you so much, ma'am. Thank you for such an
It's my
informative
pleasure.
session.
Right. So thank you. Good evening. Bye.
Let us meet tomorrow at 4 p.m. with another interactive session on the topic New Technologies in Cloud for AI by Siva Tirumalai sir, founder and CEO, Nasotech and Innovative Technology Business Solutions. Thank you all.
Thank you.